So hey everyone, today we're going to talk about ionic equilibrium. Now, I'm pretty sure all of you know what chemical equilibrium is. You say A plus B is in equilibrium with C plus D. And you have stuff like Le-Chatelier's principle and all that stuff, right? Now, ionic equilibrium is basically the same thing but for ions, alright? So when we deal with ionic equilibrium, we're going to take dissociation. That's what we're going to be dealing with primarily. So for example, I'll take this salt over here. It dissociates to give me a ferric ion. And I don't know what you call this, but this weird ion, SCN, sulfocyanide, I guess, I don't know. So this is ion, and when I take this, they're going to be in equilibrium. This is going to dissociate to form these two, and these two will also be combining simultaneously to form this. So I will say that these two are in ionic equilibrium because it's dissociation of this ion, and these ions are coming together to make this product. Okay. Okay. So when we're going to work with ionic equilibrium, we're going to be dealing with something called degree of dissociation. All right. If it's gonna, I denote it by alpha. And when I say it's basically the degree of this dissociation is like how we saw ionic equilibrium is dissociation of ions, isn't it? So my degree of dissociation is going to be the amount. So my alpha is going to be equal to the amount of the substance dissociated. So how much of it is actually dissociated divided by the initial amount, like how much of it did I take first. So for example, if I say my amount of substance, say I took 0.5 molar of HCl concentration, I took this and it dissociated and gave me 0.1 molar, like 0.1 of it dissociated to give me H plus and Cl minus, right? So my degree of dissociation is going to be 0.1 by 0.5, that's 1 by 5, that's 0.2. So alpha is going to be 0.2 in this case. Okay? So it's basically the amount of substance that dissociated divided by the initial amount. And keep this in mind because you're going to be using this a lot. Now when we calculate the equilibrium constant for this, K, it's denoted by K, isn't it? This equilibrium constant, for chemical equilibrium we had Kc and Kp, didn't we? For concentration and pressure respectively. But when we go into acids and bases, when we go into dissociation, you'll have the dissociation constant for acids and the dissociation constant for bases. Alright, so when I say Ka, for example, HCl dissociates and gives me H plus Cl negative. My Ka, my dissociation constant for the acid is going to be, why aren't you working? Concentration of H plus into concentration of Cl negative divided by concentration of HCl. Similarly for Kb, if I take maybe NaOH and I dissociate it, it gives me Na plus and OH negative. My Kb, my dissociation constant for base is going to be concentration of OH negative into concentration of Na plus divided by concentration of NaOH. So this is different terms which stand for different things, but the meaning is essentially the same. Alright?